So we can immediately write natural log y equals 1 over x natural log tangent x. And now we are ready to differentiate. And we will differentiate implicitly. You will get very easily used to this. It's not a big deal, but it's not a trivial technique either. So the left-hand side is
1 over y.
Yes, you can write y prime. The reason why I don't is because sometimes you may forget, like sometimes I do, the symbol, of differentiation, and I consider that as y. Maybe I even end up simplifying it with a y. Who knows? So dy over dx for me is safer. It's up to you. Good. Now the other side. Remember this, and I would like us moving forward like we did with the square root of x, like we did with, let's say, x squared or e to the x. I would like us to remember how to differentiate, or what is the answer of 1 over x prime. 1 over x prime is basically x to negative 1 prime, which is negative 1 over x squared. So if you could, moving forward, this is the ABC of differentiation. So differentiating 1 over x, moving forward, if you would be able to remember it, I don't want you to sit there and memorize it, but just once we see it several times, it should come back. It should come easily to you. So when we differentiate 1 over x, we get negative 1 over x squared. Why? Because when I get to chapter 5, 1 over x squared dx should be this. So not now, we don't need this right now, but that's why this is extremely important. Otherwise, I wouldn't insist. I wouldn't tell you, please remember that. So when we differentiate 1 over x, we get negative 1 over x squared. Okay, so coming back, when I differentiate this 1 over x, which is negative 1 over x squared times natural log of tangent x, and plus 1 over x, and now I have to be careful because I have natural log, which is the outer function, and tangent x, which is the inner function.
So then you have 1 over tan times
Secant squared x, indeed. Yes, perfect. So I'm not going to try to do anything here. The only thing I'm going to do is just rewrite dy over dx, multiply both sides by y, but y is tangent x raised to 1 over x, and that's it. So then dy over dx equals tangent x raised to 1 over x, and now I copy everything else I see. Negative 1 over x squared, natural log of tangent x, plus secant squared x over x tangent x. Yes?
Is there, will we have to simplify that any more for the
No.
answer? Okay.
No. Okay, we have 4 minutes left, so please tell me what you would like to do. Anything from here. We have 2 more meetings before the spring break. I'm trying to get close to the end of this chapter so we can get our test after the spring break. So what is left before you choose? Rates of change in natural and social sciences. We're going to look at motion and other things. We did not cover 3.8. It's covered in the previous course in pre-calc. We do have related rates, which is a major topic. Linear approximations and differentials, another major topic. And the last one, in the hyperbolic functions, I will just present 3 functions with their derivatives, not their inverses, just basic ones. Okay, so would you like to work on another problem?
45.
We want 45, x raised to sine x. Very good. So y equals x raised to sine x, and this is 45. And after this, of course, we'll stop. So what do I have to do? Because it's a function raised to another function, and there is absolutely no rule for this. No differentiation rule, I meant, of course. Right, that's the only hope we have. Natural log y equals sine x times natural log x. Now all of a sudden the right-hand side is no longer a power, but a product. And now we have to use implicit differentiation, both sides. So 1 over y dy over dx equals, now careful with the right-hand side because this is a product, and since it is a product, I have to have a sum of two different products. The first product would be sine prime, which is cosine x, times natural log x. Now I copy sine x and times 1 over x, a derivative of natural log. As you know, I like to do everything 1, 2, 1, 2, but you can twist it the way you like. I accept anything that works for you, it works for me. Okay, so final step, dy over dx equals x raised to sine x, and I copy the rest. Cosine x times natural log x plus sine x over x.